All right, what's up, everyone? So, this is gonna be a new series where I will be discussing how to do these lead code problems. Well, am I an expert in this? Fuck no. But what I'm trying to do is I want to teach and learn by teaching. As Richard Feynman says, if I can explain it to someone else, a 10-year-old, then I understood the topic. So my topic is in mind that my audience is going to be very young, extremely young. Those kids who start coding at like 10 years old, like those kind of kids. I started coding when I was 18. No, like I seriously started coding at 20 when I was 20. So yeah, I am not that good at anything. So the problem that we're doing is a two-pointer problem. I mean, the algorithm is two pointers. And then what we're doing is Leetcode 206, which is reverse a linked list. I hope you already know what a linked list is and how it works. I can just give you a quick introduction. So it's just a struct or an object where it stores the data and then the address to the next pointer or the next element. So for example, it's going to store this is data 2 and then this is next 2. And if let's say that this address is 500 and this address is 600, then it's going to store 600 right here. So it can easily go from one element to other element. I hope that makes sense. And here we will have a head in the problem. What we're trying to do is we're given a linked list like 1, 2, and 3, and we will reverse it. So let's say our head is here. This is our input. Our output should be 1, 2, 3, but my head should be here, and 2, 3, and 1 should be here. All right. How do we do that? So first thing, so the way I want to do this is that we go through each line of code. We are using the god, the master, the best person to learn lead code from, Mr. Neetcode. And in his solution, the way I understand it is that first what you have is two nodes, and first you will check if head is empty, and if yes, then you just do return head. Right? So that is the first easy check. But now what you do is you have two pointers, previous and then current. So what I will do is, let's say I have a linked list like this. I have 1, 2, 3, and then I store the next. So it's gonna be like this, next, next, and this is gonna be nil. What I will do is I have a previous pointer. I will initialize it to null. I have a current pointer. I will point, it will point where the head points. So let's say you have a null pointer, and this is gonna be my previous. Let's use a different color. Black is good. And then I have another color. Another pointer, which is current, and that's going to point right here. And then what I will gonna do is I will reverse all this arrow that you see. I will just reverse it like that and like that and like that. But it does seem easy. It's not that easy. Intuitively, what I thought first was that I will just go like current next equal previous. But then you realize that when you do current next equal previous, and first time it's gonna be good, but then when you update it, when the current comes here and previous comes here, and when you do current next equal previous, you are getting rid of the link, right? So if you don't have the link, current next is pointing to previous, then current next won't be pointing to 2 anymore. So in order to mitigate that risk, what we're gonna do is we are gonna have a temporary pointer in our loop. So what are we gonna do is I can explain is like, let's say your temp is here. So what I'm saying, temp is pointing at address 600, let's say, and this is 600. So you can say that temp is pointing at address 600, right? What I'm gonna do is I'm gonna loop through it. So while my current is not equal to nil, so this current is gonna jump, bam, 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 nil is right here. It's gonna jump. This is my head. So as long as my current is not nil, what I'm gonna do first is create a pointer. So let's say list node temp is equal to current next. So what happened is, let's say But as I mentioned, your link will be broken. But if I store my current next value in one of the pointers already, then I can restore the link or the connection between current and previous using temp. So what I can do is first I have a list node temp is equal to current next, and then what I'm going to do is my current next will point to previous. So in this one, your current next, as I mentioned, will point to previous, right? And you have that link established. Now I have to update. So my current will come here, right? Because now current next, I already saved my next. So what it's gonna do is current is equal to temp, and then, but before that, when you do current is equal to temp, you need to know that previous also needs to tag along with current. So I'm gonna do previous is equal to current. As you can see, if I do it again, I'm gonna have a new node, but now my current is gonna be here and my previous is gonna be here. And if you try to trace it again and my temp is gonna be the currents next, it's gonna be that this link is gonna establish like this: current next is equal to prev. So your current next is right here and your prev is the new prev is here. This link is gonna go like that, and that way you should be able to get it done. My job is to explain how the algorithm works. Your job is to